Neuroplasticity or brain plasticity is the brain's ability to reorganize itself by forming new neural connections. This dynamic process allows the brain to adapt to new experiences, learning, and injuries. Neuroplasticity operates through synaptic plasticity, neurogenesis, and cortical remapping. Synaptic plasticity involves changes in the strength of connections between neurons. Neurogenesis is the creation of new neurons, primarily in the hippocampus. Cortical remapping allows the brain to reorganize its functional layout in response to changes like injury. Several factors influence neuroplasticity. Age, with the brain being most malleable during childhood. Experience and learning, which stimulate neuroplastic changes. Physical activity, promoting neurogenesis and cognitive functions. And environment, where enriched settings enhance neuroplasticity, while impoverished ones hinder it. Understanding neuroplasticity has profound implications for education, mental health, and neurology. It informs teaching methods, offers hope for treating mental health conditions, and aids in recovery from neurological injuries. Techniques like cognitive behavioral therapy and brain-computer interfaces harness neuroplasticity for better outcomes. Neuroplasticity showcases the brain's remarkable capacity for change, highlighting its resilience and potential.